fifth graders, it's Mrs. Tremblay. Today we're going to look at equivalent fractions. There are a bunch of sheets attached to this that you're going to need. The ones that we're going to be writing on. The first one looks like this, equivalent fractions. And then there's a second sheet that looks like this. And there's also a fraction bar diagram that is attached. And there is a fraction number line diagram that's attached. So we'll be kind of looking through all of these things today. And you'll receive copies of these in class. So if you just wanted to examine them and look at mine, you don't necessarily have to print it out. You can look at mine and that's fine. All right, so you need a pencil for sure and this sheet right in front of you. And the first question I ask you is, what patterns do you see on the fraction bar diagram? So I'm gonna put this fraction bar diagram down. I'm gonna move my camera up a bit. And I just want you to, why don't you go ahead and just press pause and take a look at this and just give me a list of a couple of things that you notice about this fraction bar diagram. And then press pause when you're, press play when you're ready. Okay, welcome back. Okay, there's a little space on there for you to notice some things. And for patterns that you see, I see that this is one hole up top, and then all of the rest of these take up the same amount of space but have different numbers in them. I notice that whatever the number on the bottom, the denominator is, that's how many pieces the hole is cut up into. So when I have 1 out of 2, so 1/2, the hole is cut up into 2 pieces. And when my denominator is 3, it's cut up into 3. And 4 is cut up into 4. That's something that I notice. I also notice that as the denominator goes up, so it goes 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I notice that the piece that's represented as the denominator goes up, the piece gets smaller. So those are some things that you could list. You don't have to list all of those. They're things that you noticed. Now what I would like you to do is, and again, we just listed some things in this. What patterns do you see on the fraction bar diagram? Now we're gonna look at the number line diagram and see what we notice. So I'll put mine here. I don't think I'll be able to get all of them in, but maybe I'll pause on this part and then I'll scooch it up. So go ahead and press pause, take a look, and you're noticing some things about this. Press play when you're ready. Okay, and now I'll scooch it up so you can see all the rest. Go ahead and press pause and examine that. Press play when you're ready. Okay, welcome back. I noticed that this looks very, very similar to the fraction bar diagram. Here is 1/2, and here's 0 and 1. So this is cut into 2 sections and my denominator's 2. This is cut into 3 sections and my denominator's 3. 4 sections and there's 4. I also noticed that 7 is not on here and 9 is not on here and 11 is not on here. Those aren't 5th grade benchmark fractions, so I left them off of this number line, but you can see them as bars on the front, so that's fine. Maybe you also noticed that, again, as the denominator increases, the piece size decreases. All right, and all of those are equal to 1. So any of those things, or maybe you notice some other things, will be fine for you to write on the what patterns do you see on the fraction number line diagram. All right, I'm gonna scooch this up a little bit. So I'm not gonna write all of those things on here, but you should have some things written on your paper. Now let's chat a bit more about some things that we're seeing and we'll write down some things together. Okay, so we've done these first 2. We've noticed our patterns. It says a blank fraction has a numerator of 1. So when you look at this, I see a whole bunch of 1s on the fraction bar diagram. Those have a special name. When the numerator, the top number is 1, that's called a unit fraction. So on this line right here, let's write the word unit. A unit fraction has a numerator of 1. And I ask, what do you notice about the size of the pieces as the denominator of a unit fraction increases? And we already said, wow, as this denominator increases, gets larger, the pieces get smaller. So let's write that. As the denominator, I'm just gonna write DEN with a little period and abbreviate it, increases, the size of the pieces decreases, gets smaller. And I asked the question, why do you think that is? So maybe pause and take a moment to try to think about, why do you think that as a number would get larger, that the pieces would get smaller? Press play when you're ready. Okay, so this denominator is telling me how many pieces the whole is cut up into, right? So think about this. If this was one whole candy bar, if you only had to share the candy bar between 2 people, each person would get that big of a piece, right? But if you had to share that same candy bar with 3 people, wouldn't each piece be smaller? And if you had to share it with 4 people, each piece would be smaller. So basically, when you break up the whole amount into more pieces, each piece ends up being smaller. So what you can say for that is, you are breaking the whole amount into more pieces. You are breaking the whole amount into more pieces. So that's why it happens. So the less people you have to share with, the more you get, right? Okay, so the next set says, and just a reminder to you, this isn't in class, so you can pause me. So if I just wrote that way too fast and you're like, wait, you're going too fast, Mrs. Tremblay, press pause, catch up, the writing's right there, and then press play. It's fantastic. All right, what kind of fractions are fractions that represent the same value? That would be equivalent fractions. Equivalent fractions are fractions that represent the same value. On a fraction bar diagram, I shouldn't say one. Hopefully I'll have yours fixed by the time I post this. On a fraction bar diagram, they take up the same amount of space. On a number line diagram, they're the same distance from 0. So equivalent fractions represent the same value. And it says that on a fraction bar diagram, they take up the same amount of space. So if you look at this, like here's one whole, right? You need to back up. And if you look here, if you have 2 halves, so 2 out of 2, that would be equivalent to 1 whole. They take up the same amount of space. If you have 3/3, that would be equivalent to 1 whole. So these are all equivalent here because they're all taking up 1 whole. They're just broken into different pieces. Now when I look at this 1/2, if I want to know what's equivalent to 1/2, if you follow this line, so 1/2 takes up this amount of space. If you follow it down, you want to look for where it would match. This is right in the middle of the bar, but right here, see how that line's open? That means that 2 of these pieces are equivalent to 1/2 because they take up the same amount of space on here. So if you have 1/4 and another 1/4, that would mean 2/4. So 2/4 would be equivalent to 1/2. Now if you keep following it down, this one again, it doesn't end right at the spot there that's in the middle of it. But if I follow it down here, I see, oh, there's that line that matches the 1/2. So 3/6 would take up the same amount of space as 1/2. And again, the 7ths, it doesn't end right at the same spot, but the 8ths, 1, 2, 3, 4/8 are the same as a half. And nope, not this one, but here I see 1, 2, 3, 4, 5/10 ends in the same space as 1/10, or sorry, as 1/2. And then when you go down 1/11, nope, it's right in the middle. But down here, I can see that this ends in that same spot and takes up the same amount of space. And that would mean 1, 2, 3, 4, 5, 6/12. So on our sheet right here, where it says, use your diagram or diagrams to list equivalent fractions. For 1/2, we said 2/4 is equivalent, and 3/6, and 4/8, and 5/10, and 6/12. Those were all of the fractions we said were equivalent to 1/2 based on our diagram. So now we're going to look at 1/3, and I want to know fractions on this diagram that are equivalent to 1/3. So if you are looking at this diagram, here's 1/3. So I want to find spaces that have that same open spot that take up the same exact amount of space as 1/3. And I notice when I follow it up, I don't see that line matching, so I can't use this one. And as you follow it down here, I'm just going to grab this paper. As I follow it down, I see that's right in the middle. That's, no. But see right here how this ends in the same spot as the 1/3? that would mean that 2 of these pieces is equal to 1 of those pieces. So I could say 2/6 is equivalent to 1/3. We'll write that down in 1 second. This one does not end perfectly, neither does this one, but the 9ths do. So it looks like it takes 1, 2, 3 9ths to take up the same amount of space as 1/3. That's equivalent. And if you follow this all the way down, it ends in the same place as 4/12. So the fractions that are equivalent to 1/3 would be 2/6, 3 9ths, and 4/12. Now I want us to look at 3/4. So up here, I see my 4ths. Let me scooch this back again. I have to go up a little bit higher, sorry. Sorry if it's making you a little nauseous, all this movement. Okay, so for 3/4, that would mean 1, 2, 3 of these pieces. So I'm gonna set my paper over the top where it ends. And as I look, I see I can't go up and end in the same spot, but as I follow it down, right here in the 8ths, that ends in the same spot, and it looks like it takes 1, 2, 3, 4, 5, 6 eighths, takes up the same amount of space as 3/4, and not here, not here, not here, but when I go all the way down to the 12ths, I can see that right here ends in the same space, and that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would mean that 6/8 and 9/12 are equivalent to 3/4. And again, equivalent just means that they have the same value, they take up the same amount of space. All right, I have 2/8 here. And when I look at my diagram, here are the 8ths, and I see 2/8, 1, 2. So I'm gonna set my paper down here. And when I look, I see, I can actually follow this all the way back up. Here's 2/8. When I follow it up, 1/4 ends in the same spot, so 1/4 would be equivalent. And as I go down, I notice 3/12. So I would have 1/4, 3/12. Okay, last one, I have 4/12. So I'm gonna look on here, 1, 2, 3, there's 4. I'm gonna set down my paper, and when I look, a ruler works really well too, or the edge of your planner. So I see 4/12 all the way down here. When I follow this up, I see, let's see, does it look like 3 9ths and 2/6 and 1/3. Okay, so we're gonna list this out. I see 1/3. I see 2/6. I see 3 9ths. So those right here are equivalent to 4/12. So these right here where I have a starting fraction, I say equals this, or equals this, equals this, equals this. This is called an equivalent fraction chain. So write the word chain on there. Now we used our fraction bar diagram that whole time. You could use the fraction number line as well, and you'd line it up the same way. So for example, for the 1/2, if I set this up at the 1/2, this sheet was just harder for me to get in the whole camera. As I follow it down, I see there's 2/4, there's 3/6, 4/8, 5/10, 6/12. So you can line it up exactly the same as you would that fraction bar diagram. Okay, I'm gonna pause after the first sheet just in case in class I break it in half. So there will probably be either another video in the same lesson or this one would appear tomorrow. But for now, this sheet right here can go on page 3 in your math journal. You can tape or glue that in. Thanks for watching.